Hey guys, welcome to our YouTube channel. The name is CAE Classics. The agenda of our channel is to explore the knowledge of CAE and all design related concerns, which is beneficial to the engineer. The all related data and information of knowledge of CAE and the design has been provided in our videos. So before start the video, don't forget to like, share and subscribe the channel. Our today's video's topic is what was the steps in FEA. So let's get start. What is finite element analysis? The finite element analysis or FEM is a problem solving approach for the practical problems. The problems are first converted to matrix and partial differential equation forms. Eventually, the partial differential and integral equation are being solved to reach the solution of the problem. The volume of the equation to be solved is usually so large that arriving solution without using computer is practically impossible. And that's why the need of different FEA software is filled. There are many FEA software available for different applications. Some are the ANSYS, Nastran, Abacus and Dyna. If you have generally used some software, even at a basic level, you might be aware that there will be some result or the contour plots based on the input that was you gave. They say this, the garbage, then in, then garbage to the out. In any FEM software, getting an answer always doesn't mean necessary that it is the right one. So you must be aware of your input data and the sequence of operation to tackle unexpected problems and get the desired simulation results. So are you ready to know the 7 various steps in FEM simulations? Step number 1. Modeling. Start the FEA software and import the CAD geometry into the FEA software. You will save a lot of time in a rework if you model your domain correctly. So pay a lot of attention to the geometry as well as try to understand the reason why you are simulating this component. Step 2, that is meshing. Meshing is a critical operation in finite element analysis. In this operation, the CAD geometry is divided into the large numbers of small pieces. These small pieces are called a mesh. Third step, material definition. The material properties are defined in this step. These material properties depend on the type of analysis that needs to be carried out. By this process, you have to tell the modulus of elasticity, Poisson's ratio, density and all other necessary properties required for the finite element analysis. The next step, that is step number 4, definition of loads. This step is about the definition of loads acting on the part of the body or the force by virtue of the weight of the component. You have to be careful about the loads definition type in order to avoid encountering problems like singularities. The next step, that is step number 5, boundary conditions. This step is mainly done to reduce the complexity of this problem from an engineering sense. For example, in some problems, the user might be knowing some initial condition before starting an analysis, like displacement of a point into the geometry. Such cases fall into the initial value problem. Step 6, that is solution. This step happens in the backend after the definition of the simulation properties. In this step, you will tell the FEA software to solve the problem for the defined material properties and boundary condition and mesh size. The next step, that is step number 7, post-processing. Any FEM software will have some form of indicator to show the user of the solution has been completed successfully. Once the solver gives this message, the variable that was displacement, one message and stress that have been calculated are presented in terms of contour plots or graphs. I think for most of the beginners this could be exciting part. A decent physical understanding of the phenomena that you are simulating is very important to validate your simulation results. It's always much better to cross-check your results and also to the solution approach with the literature or the experiments. So, the conclusion about it. The flowchart for finite element analysis or finite element method or CAE is discussed. Here is a typical overview of a FEA. After viewing the results, all or some of the steps may be performed again in order to get the desired results. Hope you guys you understand the today's topic. To know about any queries, please stay tuned with us and don't forget to like, share